Okay, going on, we're looking at question 8 of the preliminary exam paper, paper 2, the chemistry paper, question 8. We see that this got to do with electrochemical cells. Question 8, the galvanic cell represented in the diagram below consists of a Ba electrode, barium electrode, dipped in a barium nitrate solution and a copper electrode dipped in the copper nitrate solution. Assume that the cell operates under standard conditions. Alright, so we've got an electrochemical cell. Question 8.1. State two standard conditions under which the cell operates. So it's got to do with concentration and temperature. So let's answer that. Question 8.1. Temperature must be 25 degrees Celsius and the concentration must be 1 mole per dm cube. Concentration, this will be the concentration of the solution of the electrolyte. Must be 1 mole per dm cube, right? 8.2. Let's look at the question. 8.2. Which cell, A or B, is the cathode, right? A or B? Now, what you should do here, we see that usually when we study, we look at the zinc copper cell, right? So here we've got copper. Here we've got, instead of zinc, we've got barium. So copper is the same, but we've got barium instead of zinc. And we know that zinc is the one that donates the electrons, is the anode. Let's just go down to our half reaction table. We look at cell B. The one we usually work is standard table B. We look at table 4B, right? From the way we did it in class, right? So if you look here in the solution, we see that it must go into forms of C to show spontaneous reaction, right? Here zinc becomes zinc 2 plus 2 electrons, and then we go down, we'll see that the copper 2 plus 2 electrons becomes copper. So that's the one we learned in class. Zinc with copper. This one, copper 2 plus. Zinc plus copper. Right? Now, it's a pity I can't write on my here. So let's just see if it will work. Take this. We work with zinc and copper. Zinc 2 plus goes that way. Oops. I'm in difficulty with the writing. Okay, never mind. So we got zinc and copper. The zinc goes this way and the copper goes this way. Copper 2 plus 2 electrons becomes copper. That's the one, right? So now let's look where's barium. Let's see if we can find barium. Where's barium? Oh, yes, barium here on the top. So barium, well, basically it's on the top and copper is at the bottom. So instead of zinc, the zinc has been replaced by barium. So barium will take the place of zinc. So whatever zinc, what we learned about zinc, now it will be barium that takes the place of the zinc, right? Increasing reducing ability, the barium will be higher. So coming back to the section, so the question says, we at this place now, let's go back. So we know that the electrons went from zinc to copper. So now it will go from barium to copper. So the half cell A is the barium, that's the anode, and B is the copper, and copper is the cathode. So the question is, state which cell A or B is the cathode, right? A or B. So it will be the copper cell, which is cell B. So we must write B as the answer there. 8.2, the answer is B. The copper cell is the cathode. Okay, going further. 8.3, the question is, write down the half reaction that takes place at cell A. So instead of zinc now we've got barium. No? Barium. So we'll say what happens at barium to donate the electrons. So we'll say barium, becomes barium ions in solution by donating 2 electrons. So barium becomes barium 2 plus 2 electrons. Right, and we don't put a double arrow here because we're talking about the one half reaction that takes place. Be careful, don't put a double arrow there. Alright, so that will be what happens at reactions at half cell A, the barium becomes barium 2 plus. Write down the cell notation for the cell. So here we've got barium becoming barium 2 plus. Here we've got copper 2 plus becoming copper. So let's write that down. 8.4. So we got barium becoming barium 2 plus, right, and then we've got the salt bridge, and we've got copper 2 plus becoming copper, right. We could put in the solution and the solid here, copper 2 plus becoming copper. We could put solid there, put aqueous there, put aqueous there, put solid there. So that will be your half reaction, the cell notation for the reaction that's taking place. Alright. And then 8.5, what is the question? Calculate the EMF of the cell. So to work out the EMF of the cell, we know that the E naught of the cell, will be E naught cell is equals to E naught cathode, minus E naught anode. So basically this will be the bottom minus the top. So basically if you go back to our half reaction table here, we can see bottom minus the top, cathode minus the anode. The cathode will be our copper, which is 0.34. It's this one here, 0.34, minus the anode, which will be the barium, which will be minus cathode 0.34 minus 2.90. The anode will be minus 2.90, right? It's coming back there. If you write it down, 0.34, it's actually plus, right? Just put plus to make it 0.34 minus 0, no, not 0, minus, let's just check that again, minus 2.90. 2.9 minus 2.9, right? Sure. Minus 2.90, and then if you work that out, then the negative become a positive, so it becomes 2.90 plus 3.24 volts. So that will be the answer. E cathode minus E anode 0.34 minus 2.90, and that will give you the answer. 8.6. 8.6.1, 8.6.2. So if you look at the sum, the ammonium sulfate is added to the barium nitrate solution. So how will each of the following changes influence the cell's EMF as calculated in 8.5? So barium nitrate, if you put ammonium sulfate in a barium nitrate solution, you're going to get barium sulfate as a product, and that's going to be a precipitate, and the precipitate basically will affect the concentrations, etc. so of the half cell, so that will decrease the EMF of the cells. It will decrease. The temperature of the solutions is increase 8.6.2. Well, let's just write on 8.6.1. It will be decrease, right? Decrease because of the precipitate. 8.6.2. The temperature of the solutions is increased. If you increase the temperature of the solution, basically the whole solution, basically this is a cell. This is the cell that we use in our circuits, and that's going to increase the internal resistance. So the internal resistance increases because it gets hot. If a cell gets hot, the internal resistance increases, and then the voltage will decrease. So the EMF basically will also decrease. 8.6.2. The temperature increase, and this will also decrease. Okay, so that will be the answer. Because the temperature increases, the EMF increases, the voltage decreases. So we got 8.6.2. So that will be the end of question 8. We've talked about EMF, we talked about working out the EMF of the cell, we worked out cell notation, we talked about standard conditions. Okay, shukran. Assalamu alaikum wa rahmatullahi wa barakatuh.